And now we are, right, okay, good. So, welcome. So I'm going to, talk about what I like to call adversarial testing. And in particular, in the context of comparative engineering, since we're in the Compiler Academy for DATC. So in case you don't know how to pronounce my name, it's Sébastien Doeraene. I work at the Scala Center. You may know me from the Scala.js project. I'm an author and lead maintainer. And so you may ask yourself the question, who am I to give you advice on testing? Scala.js is a project with 800,000 downloads every month. It has more than 150,000 lines of code. It has zero open issue, zero open bug issues. So there must be something I do right to tell you about. So let's start with a little bit of what we're going to see. So first, I'm going to talk a little bit about what is a compiler, because we really should understand what we are testing. And an alternative title for that section would be why you should rejoice at the prospect of testing a compiler. Then I'll be briefly talking what I mean by adversarial testing. Then I'll show some lists, a couple of traps that often come up in the compiler implementations for Scala. So these are things that are always good to test, regardless of what you're implementing, basically. And most of this talk, presentation, lecture, however you want to call it, will actually be 2 case studies and practice where I will ask you to actually interact. And so let's get into it. So what is a compiler? Well, if we simplify it to the core, right? It's a thing that takes a set of source files and as input and produces a set of class files, or SJSIR files or NIR files, but really this is all the same. But that's really a simplification, right? There are other things. First, it's not only the source files, it's also a set of dependencies in the form of jars or directories with class files. But that's still not quite the full picture. In fact, we're not really interested in the very precise output of the compiler. What we really are interested in is whether that output class files, whether if we run them, what is their output, right? Because we don't really care about the nitty-gritty details of how we encode things as long as they run correctly. Right? So this is really what we're looking at. And so on the left, we have a set of dependencies and a set of source files. And at the very end, we have an output of a running program. And this is what we test, actually. So given a set of input dependencies and a set of input source files, the compiler really is a function that computes a set of class files that if we run them using a given runtime, for example, the JVM, it produces a particular output. So basically it's a function, right? A compiler is a function. Okay, it's a very big, very complex function, but still a function. And we know that this is an ideal scenario for testing, right? We have inputs, outputs, and in the middle, it doesn't really matter all the details of what's happening. All we really care about is whether for the given input we have the expected output. And normally, this is deterministic. So we can write zillions and zillions of tests that are never going to break. They're not going to get flaky. Well, of course, sometimes it does happen because of some weird effects, But for the vast majority of what we're testing, we're really testing deterministic function. And that's really great. So you should rejoice at wanting to test a compiler, because if you compare that to testing distributed systems with multiple points of potential failure or slowdowns or whatever, if you have to interact with a database, or you have to, all these integration tests, this is not something that we have to do. So basically, we're just doing unit testing of a very big function. All right. So that's just to hopefully spark a little bit of excitement about testing a compiler. Now, adversarial testing, what does that mean? Well, it means nothing. I mean, if you Google for that term, you won't find any authoritative source that will tell you what it is. It's what I like to call it. The term is actually used in the security community. So adversarial security testing, penetration testing is one kind of that, right? There's a nice short article from Pam-Marie Guzzo from just a month ago, where she also entitles that adversarial testing, and it's about what I would like to talk to you about today. So I'm really happy that I found this blog post. And it boils down really to one thing, which is do not trust your code, nor anyone else's for that matter. And instead, do want to break the compiler. Right? Your goal while writing tests should not be to demonstrate that what you wrote is correct. It should be to demonstrate that what you wrote is wrong. You should try your very best to break the code that you just wrote. And that includes, in the context of compilers, with erroneous source code. You should try to break your code using source code that's not valid. And the question then is, does the reported error make sense? Is it a nice compiler error, or maybe it's a nice runtime error? But it's definitely not a compiler crash or anything like that, right? The user of the compiler should be able to make sense of it. So getting really into the specifics of a Scala implementation, this is a list of things that I encounter very often, and where the difference between one to the other will make the code break. So they're usually good candidates to really break code. So remember, I'm mostly familiar with everything that happens in the compiler after typer. So this is biased towards everything that happens after typer. For people in issues who work really in the type checker, it's probably a different set of common things that will pop up, but that I'm not so knowledgeable about. So anyway, for everything that comes after typer, the difference between int, unit, nothing, string, any arbitrary reference type, and a value class reference type, these 6 things are always nice to test because they will trigger different code paths in the compiler and so potentially break something. Another set of things to exercise is val, var, def, and lazy val, because although at the source code level, at the language intuition level, they're very similar, in the compiler, they trigger different code paths everywhere, and so they will likely break what you initially wrote. Another set, if a class versus a trait versus an object. If for some reason you happen to work in the Scala.js related area, there's a difference between a Scala type, a native JS type, and a non-native JS type. those three things trigger different code paths as well. Private stuff, like it's very often we overlook that. We test extensively with public definitions because it's just a test, right? So who cares about visibility and stuff? But in fact, private members, especially when they're in traits and or when they're accessed from companions, companion object or companion class, they trigger different code paths in the compiler. They get transformed in a very different way from public members. And so they are very good candidates to make code crash. If what you're working on is before erasure, try with generics, and especially generic value classes, because they're really nasty. Nested classes, traits, objects, defs. And I already said that before, but it's always worth repeating, error conditions. So what shouldn't compile is something you should test as much as what is supposed to actually work. And of course, you can make combinations of all of the above. And then did I mention value classes? Value classes, you do anything that's in the backend of the compiler, you must have a test for value classes because I guarantee you they will break your code. All right, any questions so far? Because that's about all I have in terms of theory, and after that we're going to go into practice.
No questions.
All right. Then let's go into case studies and practice. And so here I encourage you to unmute yourselves and try to follow along and to interact. So I prepared so I will actually give examples in the Scala.js code base and not in the .c code base, because those are examples where I have a history of commits that have lots of tests, because what I happen to write in the .c code base is mostly giant internal refactorings that don't change what the function does as a whole. It only changes how it works. So typically they don't come with additional tests because the tests are already there. But in Scala.js I have some stuff. So here my first case study is a bug that was recently reported and subsequently fixed. So I unfixed the bug so that we can now look at it together. So this is the bug that was initially reported. It says that if I have a default parameter, maybe I'll make this bigger, I don't know. If I have a default parameter in a method of a native JS trait, and that default parameter happens to have type units, the compiler crashes. So remember my list of things that make things crash? Well, unit was one of them, and we were not diligent enough. We did not test that particular stuff with units, and we got bitten. So someone found a bug with combining units with default parameters. So there was some initial diagnosing of the problem, but I will spare you the details there. We'll just show you the difference, the piece of code that solves it. So here we are in the backend generation. We are transforming a block, so a block with several statements and a resulting expression. And what we find is this shape, which would normally not happen. It would not happen for anything but units. So for anything but units, all we have is this that reaches the backend, whatever that means. But if it's units in a default value, we receive that. speaking about different compiler code paths, right? It's just different for some reason. But what we really need for the rest of the code to work is to get that. So this piece of code just recognizes that shape, right? It literally recognizes, do I have an undefined param followed by undefined, which is this thing, and then nil, then I will just keep the undefined param and throw away the other one. It doesn't truly matter, but so this is the code that fixes it. And I have written one test, which is here. I found the test about interoperability with JavaScript that says handle default parameters. Sounded like a good candidate. And I added one test with that references this method here, which takes a parameter with a default value and a type of unit, and that then calls it without providing that value, right? I only call it with one argument, but it takes a second argument which has a default value. So let's run that test. I'm going to keep it to, are you computing? Yes, you're computing. You can do it. So you can already start thinking of other tests that would break my code. No, it's not there. So what have you got? What test could I write that would try and break the code? So that passed. Okay, all good. So we're here.
Something with nothing?
Something with nothing.
Like a default parameter of nothing. I don't know if that makes sense.
Yeah, this is a bit tricky, right? But we can definitely try it. Let's try with a nothing param. I'm not sure how we'll make that work, but let's see if at least the definition compiles. Okay, the definition compiles, so that's already something. Can we now call it in any way? So that would be nothing param, and yeah, that works. Okay, so let's see if that compiles or crashes. I'm curious to know. It does compile, okay. Well, obviously the test is going to fail at runtime because it's going to throw an implemented exception, but it did compile, so no, it passed. Why?
It failed, it says.
No, it failed zero.
It passed and failed at the same time.
No, it's just an assumption in one of the 150 other tests in that source file that failed, but it's just an assumption. But that test we just wrote, it actually passed. Yeah. So how? Well, that is it's actually very interesting. It turns out that so this is a native thing, right? We saw it in the bug report that this is native. So we're actually calling into JavaScript and so the default value is not actually used. We just trust it to JavaScript to do something with it. And what we're calling is always the same fun, which is here. And that thing actually just says that we passed exactly, so it returns exactly the list of arguments that was provided. And we did provide a single unit, so it does match the expected just unit. So this is actually a surprising test, and thank you for thinking of it. Because I did not know that it would work, but it does, and we should keep the test because I don't think we have a test like that yet. Excellent.
We should do like a custom value class next.
We should do a custom value class next, absolutely. So I'm pretty sure we must have a definition of a custom value class. Yes, we have some value class here, excellent. What does it take in int? What are you doing to me? So let's use that. No. Copy that line. Please see param. Some value class. It was called 42, but I don't provide the other one. Let's just keep it that way so that we actually see it fail once. It's always reassuring to see a test fail because otherwise you wonder whether you're actually testing anything. Okay, it's not happy. That's because the first parameter is not actually a
Yeah,
value.
it's int.
Let's make it a sub-value class as well. So at least it doesn't crash. That's already good. It's always very frustrating to use the Scala compiler while using Zoom because Zoom pumps all the computational power. Okay, the test did fail that we wanted. So let's now make it hopefully pass. So I want to check that I received that guy, but not a second argument. That's right. This should work, I think. Yes, it does. Good. So we could probably go along the list. I'm pretty sure the other ones are well covered. Let's try and think of something different. Maybe I'll bring up the list again. See anything in there that's in particular? Since we're doing we're actually dealing with the Scala JS bug involving JS native stuff, so.
How about a class with a default parameter?
A class with a default parameter of type units. Yes, yes. We can put default parameters for constructors. So we have something here. Let's define another one because but we'll probably want to give it the same name as this one. So we should have, no, in this case it's unit. No, it's, what does it say? Yes. No. What is wrong? JSON of int required any value. You probably want the implicit type here.
Because the 10 and the unit.
Yeah, but no, I think the n here should fix it. No? What the Scala C says. No, Scala C is not happy.
This value is really wants area.
Oh, it's an array of ints. Okay. So did I read the test correctly? Yeah, because that one creates an array of the two arguments. Yeah, okay. But no, we're using that guy, so it's going to be 8 anyway, right? No, we can't have that. So unit isn't defined, just in case you didn't know. And I need to change that definition now. So it did complain that it's expected undefined when it was 8, but now it should be happy. Yes. Good. I didn't manage to really break my code yet. Who can think of something else that might break it?
We've recently had issues with class with a var defined in a definition of a method. So like an inner class in a def with a var. Can a var have a default value? I think so. So like a var with a default value inside of that. I know it's a bit complex, but
I'm not sure I got it right.
so if you have a first method and inside of that method a class with a var.
Oh, yeah, is not actually relevant in this specific case, but you wouldn't know because the JS native class cannot be defined inside a def. It has to be defined in a static context.
Okay.
So we're lucky in the sense for this specific case that we're only dealing with JS stuff and they can't be defined in a non-static context. So that's one source of things that don't happen. We should definitely test that it's actually rejected by the compiler, but that we have. It's all right. We'll skip because it strays a bit further from this specific bug that we're looking at.
But what about a class with var as a parameter and that of type unit? Can we do that?
We can do that, but it's not in this specific case. So if I make this one a var, it
will be the
really
same.
changes nothing in terms of, I mean, those two things are completely separate in the compiler. The fact that this is a var and the fact that it has a default value. The default value is for the parameter of the constructor and the var becomes a field, they're disconnected. So in this case, it won't, I mean, we could do it, but it won't show up anything interesting.
Okay.
So I'll just try and nudge you a little bit in the direction where you can actually break my code. So yeah, spoiler alert, there is a way to break my code, it's not correct. So I'll just look here again.
Native JS types.
So we are dealing here with a native JS type. That was the bug report. It was about native JS types.
About the unit as native JS type.
About units as a default so a unit param with a default value in a native JS type. And now maybe we can do a unit param with a default value in some of these other things, a Scala type or a non-native JS type. This is, right? Which one do you pick? Which one do you think is most likely to break my code?
Scala types.
We have diverging, but let's try the Scala type. So that should be anywhere but here, but since we're here, and we can make them val, so that we'll be able to yeah, this is actually not the best way. No, this is not what I want to. That's this one, right? String, and we'll return x, y. Okay. And so we want to test that we receive, so this is not going to be an array. We should receive something like 5 undefined when we call, no, what did I do? Scala class. And I pass in 5 and no arguments. It's not happy. No arguments allowed for nullary cons. Oh yeah, no. It's .2 5. Assert equals. All right. Not crashing. But it works. Let's try the other one. The non-native JS type. So the only difference is that it extends JS object, basically. But that triggers, I mean, it's completely different semantics, so exactly the same thing. And I kind of killed the suspense earlier, but still curious. It's supposed to fail. Yes, it does. All right. So what does it say? But we broke it. I had to nudge you a little bit, but we're there. So Java long void expect. So this is an IR checking error. So this is actually the equivalent of a verify error from the JVM, right? So we generated what amounts to invalid bytecode. The SJS IR file doesn't type check. It's completely bogus. It expected a Java long void, but it got no type. No type is like the primitive void, right? It's a statement basically, and wanted a value of type Java long void. And it found that at 1165, so that's the definition somewhere. So at the definition site of this method, something broke. And so I won't go into the details of how we fix that because that's kind of irrelevant. The fix is here. Because of course I knew about this beforehand. And the reason I knew about this beforehand is because when I fixed the other bug, I actually thought about trying in a non-native JS class as well, and I hit this failure, of course. So none of this is, so the commit that fixes, yeah, but you didn't recompile it, huh? Yeah, let's add a space here, then we'll force it to recompile.
Whoa.
Okay, what's, oh yeah, that's Windows. No, stop. I have to restart SBT every time I do that. So yeah, if you work on a compiler plugin on Windows and you use the compiler plugin from another project in the same SBT build, every time you change the compiler plugin, you have to restart SBT. There you go, so you know. Okay, so while we wait for this to compile and I think succeeds, let's reflect a little bit how come we actually like got there. So this is really, so of course, I mean, I'm putting you in the Scala.js environment and it must be a bit difficult to really try and target to be in attack mode, right? And even though I'm trying to make you attack my code, I understand it must be a weird feeling right now for you. Really, this is okay. I fixed one bug, but I'm not content with that. I'm not content with writing a test for that bug. I'm really looking at, okay, what are all the different variations I could make on the tests that exposed the bug. So here it passed. What are all the different variations, and especially the variations coming from that list that I can think of, and where I'm going to really work at breaking the code I just wrote. Right? It's really the trick is be your own opponent, which is why it's called adversarial testing. You're trying to beat the code that you just wrote, and you're really trying to break it. And these are the tools that you can use to break it. Really, at least for everything that comes after Typer. For everything that's in Typer, it's really a different kind of thing of lists. But okay, any questions? Otherwise, I have another case study, which is a feature this time and not a bug. No? All right. Still motivated to look at another one? So this is yes. Okay. So let me commit this, and I have another branch coming for you. So this time we are in new target test. Yeah, and so so this is a feature that we actually did not implement, and I implemented especially for you guys and girls yesterday. So we have this missing piece in the interrupt story of Scala.js that we can use We can access the JavaScript new.target magical thing. You don't want to know about it in classes, but we cannot do that in functions. So the idea is that, so already in today's Scala.js, we can write something like this. We can write any trait of your own choosing that extends JS this function. And that is going to be a JavaScript function value whose first argument is this special value of JavaScript, and the other arguments are going to be valid values. So we generalize this thing by defining a new magical trait, which is new target this function. And this time, if I have a trait that extends that thing, the first two parameters are special. The first one is going to receive the new.target magical value of JavaScript, and the second parameter is going to receive this magical value of JavaScript, and the rest are the normal arguments. So I can use that in a SAM like this. So I can define a constructor with that type, and its implementation is a lambda, but this is not a Scala function type, but it's a SAM type. So the compiler can adapt the lambda to fit the SAM type. And we test something here. We test that if new target is undefined, we throw a nice illegal argument exception, and otherwise we initialize the object with its parameter. So this is really checking that we're always going to call the constructor with new. Because in JavaScript functions and classes, they're the same. But if you call it with new or without new, things happen differently. In particular, this can test whether or not it was called with new. So we have a test here. So here I'm in my hello world. It's not yet in the test suite and everything, but it's, where I call it without new, and I verify that I can actually catch the arguments. Here I try to call it with new, and I check that the field was initialized correctly. And here I'm calling it as a function without new, but explicitly passing a value for this parameter. Okay, so this is my hello world. I'm going to make it run, and in the meantime, I'm going to show you the code that implements that. It's not much. So I first test here if the SAM I'm implementing is a subclass of this magical trait, the one we just defined. And if that's the case, when I generate the Scala.js IR, what you can think of as JavaScript code, I extract the first two parameters. The first one is going to be new target, second one this, and then I arrange things here so that the first two values are initial. So this one is initialized with new target, and this one is initialized with this, and the rest is passed as is. So basically, we are looking at this piece of code. This is my feature. I'm implementing that in 15 lines. And now let's break it. So who wants to give it a shot? Just looking at the implementation here, I'm sure there's something that must jump at some of you, that this code sounds like I can break it somewhere, somehow. No? I'm doing something very snazzy here. Like if you're Scala programmers, you should be jumping at me like with both feet. There I'm constructing but it says mutable equals false. So that's okay. That's okay. Yeah. No?
Is it?
What could possibly fail here? how do I make this code crash?
Pattern, maybe the first one, you extract 3 parameters.
Well, two and a tail. Yeah.
Could we see maybe less than?
Maybe it could receive less. Yeah, maybe it could receive less. Let's try and make it receive less. All right. It doesn't go, because there is a discussion. I need to drop off. Oh, okay. Well, see.
We have 3 minutes left. This meeting room.
Oh, yeah, but I think no one comes after.
Okay.
My hello world, let's try to make it receive less than 2 arguments.
Create another.
I can create another like this.
Is it just a marker trait? No.
It's a marker trait. It contains nothing.
My error. Can have another apply method.
Let's remove that and apply methods. A second one? Or
No, just one.
are we changing this one?
One T1.
Just one argument?
Oh, yeah.
This?
Yeah.
I removed the generics to make it simpler, right?
Mm-hmm.
Okay. And let's try to then define one like that. So this will be in my evil equals, so just an I like this, and then let's try to, probably want to show you that as which is dynamic, otherwise I can't. So JS dynamic new instance of C41, and I'm going to pass to a few parameters. The access one will be dropped anyway. All right. So let's try this. Oh, the previous thing did not. What? Oh. No, but it's the same issue again. I'm just going to comment this because I want to verify that what we have before actually works. I changed branches, so of course the compiler code changed, so it's a Windows issue. I'm always impressed at how, oh yeah, that's expected. Okay, so we did catch the legal argument exception the first time around, and then the second one was not protected here. So that is expected. Okay, so that did work. So let's now try the suggestion from Adrian. And let's see what happens. Yay! We got the crash. Nicely done. Error, well, everything hello world at Scala. It's always great because it doesn't give you a stack trace. It's apparently a match error. So, all right. So what do we do about it? Let's go back to our code here. Or first, perhaps before looking at the code, like what of the compiler, what should this do? Anyone? What if?
I don't understand because it's dynamic, so there's no type information.
Well, it's this line that crashes actually. I mean, it's the very creation of that thing. But what we're doing here is it's like as if we were writing the JavaScript code, new CTOR2 with 1, 2, and 3. It's just
that's like a syntax.
It's syntax, but it really means that in JavaScript.
Okay.
We're using dynamic to really poke at it the way JavaScript would poke at it.
There is something I don't understand. The my new target function.
Yeah.
There is an implementation missing. There is a method missing. The first one.
This one?
New target this.
This? There's nothing in there. It's it's an marker trait.
Uh-huh.
So the IR transformer, does it look for just anything that extends the new target this function?
You should have compiled them.
We're getting there.
So signature of this.
We're getting there. So yes, it's new target function, and it basically tests is the symbol of the SAM is the subclass of this new target this function to the marker trait. So actually, I was very purposeful in not showing you this part of the code because you can already see here that for the regular this function, which already has one special parameter, we have an explicit check that makes sure that the params are non-empty. Right? So of course, we want to generalize that and make it not compile. So this is reporting a proper compiler error. So we can take something similar and test that they're non-empty, but also the tail is non-empty. And
Or sign is greater than.
target, yeah, but that's more expensive.
Okay.
Must have two leading non-var RX parameters. So let's compile that, and I'm afraid I'll have to restart this again.
There's a size is method that's cheap.
Yeah, but see, this code cross compiles down to 211.
Oh, never mind.
And you can even see that the default version I use for all my tests is 212. And why not 213? Well, because of the linker, which is an SVT plugin, so it's 212. So if I test on a regular basis with 213, it compiles more. So now we got a very nice, precise compiler error that points at the right place, and it specifically says that the SAM for a new target this function, it must have two non-leading RX parameters. Can anyone think of another way we could break this code? So for context, yeah, I'm kind of already will probably give away some of the possibilities, but
Two function arguments that are not the right types.
two function arguments are not the right type. There's
But the new target is any, so that could be.
it's two
Convention.
any's. It's you choose what goes there, and
Oh, I see.
it's going to be
So
fine.
right.
Yeah. I mean, you probably want this to be a super type of unit somehow, or of undef or something, because new target can always be undefined. But that's going to be a runtime error. Something else yeah.
Is it overloading apply?
Overloading, well, I mean, yeah, but so let's say we have another parameter here. The thing is that, so now this is not a SAM type anymore.
Okay, so
So,
yeah.
oh, shoot. Yeah, so even if So now it says, I mean, it's not even applying the SAM treatment to this thing, so it failed way earlier. You have booked a room?
I booked the room for 3 o'clock.
Okay, sorry, then we are moving on. Sorry. Well, it's been a pleasure. I hope you like this. And yeah, happy testing and break some code.
And then test it.
And then fix it.
Thank you, Sebastian.
All right. See you.